Welcome back to OCR MEI Further Mathematics B. Today we're doing chapter 6.4, Partial Fractions in Integration. This we have actually already done before during the previous sections when we need to do some form of partial fractions, at least I think, but I'm gonna do it, I'm gonna talk you through how to do it again right here. It is again partial fractions, so once again, if you don't know your partial fractions, do go and revise for it, because a lot of topics depends on this very thing. So why don't we start on a practice question where we have 3x plus 11 on x squared take x takes 6, and we need to integrate this expression. So again, note the dx. So integrate by dx is essential when you write an expression for integration, the dx. A lot of people miss that out, and that makes no sense. So first of all, let's try to separate this whole thing out, because for now we cannot actually do anything to it. So the first step would be to first factorize the bottom to x take 3x plus 2. So that's the same expression on bottom, the 3x plus 11 on top, and now we can do partial fractions. So we take a on x take 3, b on x at 2, add them together, gives us that expression. So I'm gonna skip writing that because that's just tedious, which gives us a times x plus 2 plus b times x take 3 equals 2 3x plus 11. So what we can do now is to again eliminate one of the a and b variables. So let's take x as minus 2, take away that minus 2 gives us minus 5b. So minus 2 times 3 minus 6 plus 11 is plus 5, so we can deduce that b is actually just minus 1. Now do the same for the other value of x, which is 3. So we have 3 times 3 is 9 plus 11 is 20 equals to 3 plus 2 is 5 lots of a, which gives us a equals to 4. Which is very straightforward. We've got these sorted, so we can just plug in the numbers, and that would become 4 on x take 3, and actually take away 1 on x plus 2. And now we need to integrate this by dx, which we can do. So there's a trick when it comes to integrating a fraction. If you differentiate the bottom, let's take 4 on x take 3. So if you integrate, if you differentiate the bottom, you should get by just 1, because the coefficient of x is 1. So as we know, to integrate this, we need to chain rule. But turns out that if the top value is the same as the differential of the bottom, so if the numerator is let's see, numerator n is equal to the denominator d differential, if this holds true, then the integral of n on the integral of n on d is equal to just the natural log of d. This is well, you need to add c, and you need to define your d something, I don't know. So if this holds true, n equals to d dash, in this case, this does not hold true, because the differential of d is 1 and n is 4. But we can factorize, so we can take out the 4 in front of the integral to get 1 on x take 3 dx, take integral of this thing. I'm kind of out of space, I'm just going to ignore that for now. With that, now this one holds true, so you can just write natural log of x take 3. So that would give us for ln x take 3. Note that this is the domain has to be positive, so we modulus dx take 3. It works right now with this 4. It works here as well, so let's try that. This time we have -1 on top, which is not really what we want, so we take -1 out of the integral, we get +1, so we have just take natural log of x plus 2. Again, modulus sign for good measures. I might have explained this natural log trick a bit badly, but if you can apply this natural log rule, then it's actually really fast. So if I have, say, x squared take 3x plus 5 on 2x take 3, then if I say integrate this by dx, I can just literally write natural log of x squared take 3x plus 5 modulus, without even thinking, because the bottom differentiated is 2x take 3, which by chain rule cancels out. So yeah, this is very helpful, a very time-saving trick that I want to share. But if you can't do that, just do the usual substitute u equals to x take 3, etc. Then do the du dx chain rule thing, and you should be able to get the same expression by the end, which in this case is for natural log of x take 3 in modulus, take natural log of x plus 2 in modulus, plus c. Yeah, basically my tip, don't forget the plus c. It's extra large here, extra large for good measure, just in case you forget. Plus c, important. Also, the natural log integration trick, very helpful. If you can't do it, however, don't worry about it. It's helpful to save time, but it's not essential, so do it the long-winded way if you have to. And also practice the natural log trick would help you during your exam. Okay, so question time. We have 3 questions today. Evaluate the following expressions, and as usual, they are kind of, let's say, quite straightforward. Normally don't set something too difficult, because there's no point. Practice makes perfect, so I'll give you again 5 seconds to pause the video and do some of the questions, and I'll show you the answer in 5, 4, 3, 2, 1. And there we go with the answers. So these are quite, again, straightforward. I made a mistake here. This should be a modulus symbol, not a bracket. And there should also be a modular symbol over here, so that's my bad. Other than that, this normal bracket is fine because x squared is always larger than 0. Plus 1 is always positive, and so natural log, any x value would work for that expression. Can't speak today. So yeah, that's all for this video. I hope you have learned something. If you have any questions to do with partial fractions integrations, do let me know in the comment section below. But for now, thank you very much for watching, and I will see you on my next one.